Welcome, dear listeners, to another serene journey on the Dreams of Gravity channel. I'm so glad you've joined me here, in this quiet space where the universe unfolds like a gentle whisper. If you haven't already, please find a comfortable position, perhaps lying down in your bed, or settling into a soft chair with pillows cradling your form. Let your body sink into relaxation, your breath slow and even like the quiet tide of an ocean at rest. Close your eyes if you wish, and allow yourself to drift into the atmosphere of this story. Tonight, we'll explore the secrets of our solar system, those hidden wonders the world has yet to fully uncover. Let the words carry you, soft as starlight, into a peaceful slumber. Imagine, if you will, our solar system as a vast, breathing entity, a cosmic ocean where the sun is the steady heart, pulsing warmth and light across endless waves of space. At its center lies the sun, that radiant orb we've known for millennia, yet its deepest secrets remain veiled, like treasures buried in the silken sands of a midnight shore. Scientists tell us the sun is a star, born about 4.6 billion years ago from a swirling cloud of gas and dust, much like the breath of creation itself. But what the world hasn't yet discovered are the subtle rhythms hidden within its fiery core, whispers of magnetic fields that dance in patterns we can only begin to map. These fields, twisting like invisible currents in the ocean, shield our solar system from the harsh winds of interstellar space. As you listen, feel your own breath aligning with this solar pulse, slow and reassuring, inviting you deeper into rest. Consider how the sun's surface, that bubbling photosphere, erupts in solar flares, gentle bursts of plasma that arc into space, carrying particles that sometimes dance as auroras across distant planetary skies. These flares, born from tangled magnetic lines snapping like threads in a weaver's loom, remind us of the universe's quiet artistry, crafting light from tension, much as a deep sigh releases the weight of the day. Delve further into the sun's corona, that ethereal halo visible only during eclipses, extending millions of kilometers into space, heated to millions of degrees by waves of magnetic energy rippling outward. This puzzle of why the outer atmosphere burns hotter than the surface itself eludes us still, a mystery akin to how a whisper can stir the soul more than a shout, suggesting hidden mechanisms that propel particles to near-light speeds, seeding the solar wind that caresses every world in our system. In this solar breath, we find a rhythm that mirrors the ebb and flow of sleep, where energy builds and releases in harmonious cycles, sustaining the delicate balance of life across the void. Heliosysmology, the study of solar vibrations like gentle ripples on a pond, reveals internal layers where convection carries heat from core to surface, a convective ballet that drives the 11-year sunspot cycle, waxing and waning like phases of the moon, influencing earthly climates in subtle ways that connect our daily weather to stellar heartbeats. Granules on the photosphere, rising cells of hot gas about the size of Texas, churn like a slow-boiling soup, each lasting mere minutes before sinking back, a granular landscape that shifts with the sun's rotation, faster at the equator than poles, a differential spin that twists fields into knots, fostering the storms we observe, much like how personal rhythms vary in the quiet cadence of evening contemplation. Prominences, loops of plasma suspended by magnetic arches, can erupt into the corona, casting shadows that silhouette against the disk during total eclipses, their slow motion a graceful arc lasting days, drawing energy from the sun's vast reserves in a display of stored potential released softly, akin to the gradual unwinding of thoughts as one approaches the threshold of dreams. Faculae, bright patches around sunspots, mark regions of intense magnetic activity, emerging like faint glows before larger disturbances, their network contributing to the Sun's total irradiance variations that subtly modulate Earth's seasons, a stellar influence woven into the fabric of our growing things and changing skies, reminding us how the distant fire shapes the intimate patterns of daily life. Spicules, slender jets of plasma rising from the chromosphere like delicate grasses in a breeze, carry material upward in a perpetual fountain, feeding the corona with fresh energy and tracing magnetic field lines that connect the Sun's layers in an invisible architecture, a subtle circulation that sustains the star's outer glow, much as quiet aspirations lift the spirit toward unseen horizons in the calm of introspection. Coronal mass ejections, massive bubbles of plasma hurled into space, sculpt the heliosphere's boundary, compressing Earth's magnetosphere during passages that spark widespread auroral displays, a solar exhale that reaches across the system to touch our world with fleeting beauty, evoking the way a shared sigh in conversation can bridge unspoken distances. Nanoflares, tiny bursts in the quiet corona, may collectively heat the outer layers, a multitude of whispers building to a sustained warmth, like the accumulation of small kindnesses that nurture a lasting inner peace over time. The Sun's tachocline, a thin shear layer between radiative interior and convective zone, incubates magnetic dynamos, where differential rotation winds fields into complexity, a boundary realm where stability meets flux, much like the subtle divide between wakefulness and the first veils of sleep. Rossby waves on the solar surface, large-scale undulations propagating westward, modulate the dynamo cycle and influence active longitudes, a fluid whisper that aligns sunspot emergence like a gentle current guiding leaves downstream, fostering a predictable yet evolving pattern in the star's magnetic life. Our nearest companion, Mercury, orbits closest to this solar heart, a small, rugged world scorched by the sun's embrace. It's a place of extremes, where days blaze hotter than an oven and nights plunge into frozen silence. Yet, beneath its cratered surface there may lie secrets of water ice tucked away in shadowed craters, remnants of ancient comets that wandered in from the outer edges of our cosmic sea. Imagine Mercury as a quiet sentinel, holding these frozen whispers, untouched by time's relentless flow. We haven't fully uncovered how these hidden ices might have sparked the first flickers of life elsewhere, but they remind us that even in the hottest fires, cool mysteries endure. Let this thought ease your mind, like a cool breeze on a warm evening, carrying away the day's tensions. Deeper still, Mercury's thin exosphere, a mere veil of sodium and other atoms, glows faintly under solar wind's caress, scattering light in ways that hint at processes we scarcely understand. It's as if the planet exhales particles into the void, a subtle respiration echoing the slow inhale of sleep, where every element finds its place in the grand, unhurried cycle. Seismic echoes from meteor impacts suggest a partially molten core, larger than expected, generating a weak magnetic field that deflects some solar radiation, much like a faint shield in a storm. This inner liquidity, a remnant of formation heat, speaks to Mercury's resilient core, preserving motion and stillness, and invites reflection on how such a diminutive world endures, orbiting in 88 days while tidally locked in a 3.2 spin resonance, a resonant dance that stabilizes its gaze toward the sun, like a meditator holding focus amid distraction. Polar wander, where the planet's axis shifts over time due to crustal adjustments, may have redistributed ices, creating calderas like the Caloris Basin, a vast impact scar whose antipodal waves rippled to the opposite side, fracturing the ground in chaotic patterns, a reminder that even small worlds carry the echoes of cosmic violence, now settled into tranquil repose. Hollows on the surface, bright depressions etched by volatile sublimation, suggest recent activity, perhaps from solar heating releasing trapped gases, a fleeting geology that hints at Mercury's ongoing whisper of change, like the subtle shifts in breath as one settles into deeper rest. Escarpments or lobate scarps wrinkle the crust from contraction as the interior cooled, towering cliffs hundreds of meters high, mapping a history of shrinkage like the folds in aged parchment, where the planet's form adapts without breaking, embodying a quiet resilience that parallels the way we fold into comfort during repose. Volcanic plains covering much of the northern hemisphere indicate early effusive activity, smooth expanses punctuated by ghost craters buried under lava flows, a testament to a youthful phase when Mercury poured out its inner substance, now hushed into a landscape of subtle undulations that catch the slanting light of its long days, evoking the calm after a creative outpouring. Radar observations of polar deposits reveal not just ice, but possible salts and organics, hinting at cometary deliveries that altered the surface chemistry, a quiet infusion of complexity in an otherwise barren realm, where these compounds might have simmered in shadowed nooks, precursors to more intricate forms, much like how overlooked moments in life accumulate into profound inner landscapes. Intercrater plains, transitional terrains between highlands and smooth basalts, preserve impact rays that fade over time, a fading memory of bombardment eras when the inner system was a forge of collisions, now smoothed into a contemplative expanse where the planet's history lies layered like pages in an open book under faint starlight. Pyroclastic deposits, rare vents of explosive volcanism dot the surface with bright halos of ash, evidence of gas-rich eruptions in Mercury's past, now quieted into subtle mounds that whisper of a time when the planet exhaled its inner pressures gently, much like the release of pent-up reflections in the stillness of evening. The planet's true polar wander, inferred from crustal features, suggests a reorientation early in its history, perhaps stabilizing the magnetic field against solar erosion, a slow realignment that echoes how we adjust our inner compass in moments of quiet reassessment, finding equilibrium in the face of external pulls. Regolith breccias, fused by micrometeorite impacts, form the surface's loose blanket, a powdery archive that traps solar wind isotopes, preserving a record of the inner system's radiation history like a diary written in dust, where each particle holds a trace of the sun's ancient breath. As we drift outward, Venus emerges like a veiled dream, shrouded in thick clouds of swirling gases. Often called Earth's twin for its similar size, Venus hides a world of fire and pressure beneath those clouds, a surface hotter than a forge, with volcanoes that may still rumble in secret. The world has yet to discover the full extent of its ancient oceans, long evaporated into the steamy atmosphere, leaving behind sulfuric rains that fall like golden tears. Picture Venus as the breath held too long, a planet of transformation where carbon dioxide blankets the skies, teaching us about atmospheres that can nurture or overwhelm. In its hidden depths, perhaps dormant life forms adapted to the heat, waiting for our probes to reveal them. Feel your own breath releasing now, soft and unhurried, mirroring the slow unveiling of these planetary secrets. Radar maps from orbiting spacecraft have pierced the veil to show vast lava plains and tesserae, cracked highlands like the skin of some ancient, breathing beast, suggesting tectonic shifts that once mirrored Earth's own restless youth. These movements, driven by inner heat long since stifled, speak to the fragility of planetary balance, a reminder that worlds, like minds, can shift from vitality to stillness in the quiet passage of eons. Phosphine detected in the upper clouds, a potential biosignature though debated, hints at chemical oddities that could arise from unknown microbes floating in the temperate zones aloft, where temperatures hover like a mild spring day. Venus's retrograde rotation, spinning backward in 243 Earth days, defies the norm, perhaps from a cataclysmic impact that reversed its flow, a cosmic reversal that echoes how dreams can invert reality, offering lessons in runaway greenhouse effects that warn of our own world's delicate equilibrium. Lightning in the clouds, crackling through the haze, may sustain exotic chemistry, breaking molecules into reactive forms that drift downward, while surface winds, sluggish near the ground, accelerate in the upper layers to encircle the planet in superrotation, completing a circuit in 4 days, a whirlwind that defies expectation, much like how intuition sometimes outpaces logic in the calm of contemplation. Crater scarcity on the surface indicates a resurfacing event around 500 million years ago, perhaps a global volcanic flood that smoothed the scars, leaving pancake domes and corona, circular features from mantle upwellings, ringed like ripples in a pond after a stone's gentle drop, evoking the way memories settle into layered calm. Tesserae regions, elevated and intensely deformed, may represent ancient continents buoyed by thick crust, now eroded by volcanic resurfacing, their rugged terrains a testament to a time when Venus might have hosted dynamic plate motion, faded into a stagnant lid that holds the planet's heat in a perpetual simmer, much like the lingering warmth of a day absorbed into the evening earth. Aphrodite Terra, a vast highland rivaling continents, bears folded ridges from compressional forces, suggesting a history of crustal thickening where the planet's slow spin allowed heat to accumulate without the cooling escape of tectonics, fostering a world locked in a warm embrace with its own interior, a metaphor for how unresolved energies can both sustain and confine. Beta Regio, with its rift zones and domes, hints at ongoing plume activity, where mantle convection might still stir the crust faintly, releasing trace gases that mingle with the atmosphere, a subtle vitality persisting beneath the oppressive blanket, inviting thoughts on how even stifled worlds harbor the potential for quiet renewal, like a seed waiting under unyielding soil. Ishtar Terra, the northern counterpart to Aphrodite, rises with Maxwell Montes, the highest peak in the system, its flanks possibly built by upwelling plumes that fractured the crust into ribbon terrains. A mountainous realm where ancient compressional forces left their mark in folded belts, now standing sentinel in the hazy twilight, a symbol of enduring elevation amid atmospheric confinement, much as personal peaks of experience rise above daily veils to offer perspective and repose. Lakshmi Planum, a broad plain adjacent to the mountains, may have formed from repeated lava inundations, its smooth expanses contrasting the surrounding folds, a serene plateau that captures the planet's volcanic legacy in quiet repose, evoking the calm plateaus of life where efforts settle into lasting vistas. Sif Mons, a shield volcano in Isla Regio, rises with gentle slopes from repeated effusions, its caldera a quiet basin that hints at episodic activity, where the planet's mantle once channeled heat to the surface in slow, persistent flows, much like the steady undercurrent of patience that shapes enduring landscapes over time. Mont Mons, another shield in the region, shows radar-bright flows suggesting recent eruptions, a faint pulse of volcanism that could release water vapor into the atmosphere, a hidden hydrological cycle simmering beneath the surface veil, where ancient reservoirs might still influence the planet's chemistry in subtle, ongoing exchanges. Ah, but Earth, our blue jewel, the cradle of your dreams tonight. We know her well, yet the solar system's secrets intertwined with her story remain profound. Deep within our oceans, mirroring the cosmic sea, lie hydrothermal vents spewing minerals that echo the birth of stars. Scientists suspect undiscovered microbial life in these depths, ancient as the solar system's formation, hinting at how life might thrive on other worlds. And what of the moon, our faithful companion? Its far side, hidden from ancient eyes, guards craters filled with helium-3, a potential fuel for future dreams. The world hasn't yet unlocked the full tale of how the moon's pull shapes Earth's tides, like a gentle hand guiding the ocean's breath, influencing the very rhythms of sleep and wakefulness. As you relax here, let Earth's quiet stability ground you, a soft anchor in the infinite. Beneath the lunar regolith, pockets of volatile ices whisper of deliveries from cometary impacts billions of years ago, seeding our atmosphere with water, the essence of life itself. On Earth, these same impacts scarred the crust, but also stirred the pot of evolution, much like how a soft rain nourishes the soil, awakening seeds long dormant. Our planet's magnetic field, generated by molten iron in its core, deflects solar winds, preserving the air we breathe, a protective bubble in the solar ocean that allows fragile dreams to flourish. Plate tectonics, the slow drift of continents like leaves on a stream, recycles carbon and builds mountains, fostering biodiversity in ways that tie us to the solar system's dynamic heritage. Consider the abyssal plains, vast and unexplored, where chemosynthetic bacteria thrive on chemical energy alone, independent of sunlight. A model for life in shadowed alien seas, reminding us that resilience blooms in the unlikeliest places, much as quiet reflection yields profound insights in the hush of night. Coral reefs, built by tiny polyps over millennia, form barriers that protect shores, their symbiotic algae converting sunlight into energy, a microcosm of how solar input drives global cycles, from photosynthesis to the oxygen we draw in each breath, linking our lungs to the star's distant fire. The thermohaline circulation, a global conveyor of ocean waters warmed at the equator and cooled at poles, distributes heat like a planetary bloodstream, modulating climates and sustaining ecosystems, a slow pulse that echoes the unhurried flow of time in our solar neighborhood. Mantle plumes, rising from deep within the Earth like thermal fingers, pierce the crust to form hotspots such as Hawaii's chain, tracing the plate's crawl over fixed sources of heat, a volcanic legacy that builds islands from the deep, much as inner inspirations rise to shape the surface of our lives in gradual, enduring ways. The cryosphere's ice sheets, like Antarctica's vast dome, lock away ancient air bubbles that record millennia of atmospheric change. Their slow melt a mirror to cosmic timelines where frozen moments preserve the breath of past eras, inviting us to contemplate how Earth's cold expanses hold the planet's memory, much like the quiet retention of experiences in the subconscious before sleep's full embrace. Subduction zones, where oceanic plates dive beneath continents, recycle sediments and water into the mantle, fueling arc volcanism that builds island chains, a cycle of destruction and creation that maintains Earth's habitability, where the friction generates earthquakes like distant rumbles in a dream, releasing built-up tension in ways that ultimately renew the surface. A philosophical balance of release and renewal echoing the way we process the day's events in nocturnal repose. Rift valleys, such as the East African Rift, mark the birth of new oceans as plates pull apart, magma welling up to form fresh crust, a continental parting that foreshadows future seas, where the slow stretch of land reveals the planet's ongoing evolution, much like the gentle parting of eyelids in the transition from wakefulness to deeper rest, unveiling inner worlds. Mid-ocean ridges, serpentine chains encircling the globe, birth new seafloor at rates of centimeters per year, a continuous creation where hydrothermal fluids nurture unique ecosystems, a hidden vitality along the planet's spine that sustains the ocean's depths in perpetual quietude. Transform faults, sliding boundaries between ridge segments, accommodate lateral motion without subduction. They're offsets like quiet seams in the crustal fabric, where stress accumulates and releases in measured slips, mirroring the subtle adjustments we make in relationships to maintain harmony over time. The inner core's solid iron, growing as the outer liquid layer freezes, generates additional magnetic complexity through inner core superrotation, a subtle spin that influences the geodynamo, much like an inner voice quietly shaping the flow of outer expressions in moments of introspection. Venturing further, Mars calls to us with its rusty red hues, a world of dusty plains and towering volcanoes. Olympus Mons, the solar system's largest, stands silent, its secrets buried in layers of ice beneath the surface, vast reservoirs that could sustain future explorers. We've glimpsed ancient riverbeds etched into its canyons, suggesting rivers once flowed like the veins of a living body. But the undiscovered truths? Perhaps microbial fossils in the polar caps, frozen echoes of a wetter past, or even subsurface oceans warmed by geothermal breath. Mars is like time itself, scarred yet enduring, whispering of possibilities that could redefine our place in the cosmos. Allow this image to soothe you, as the red planet's calm deserts invite a peaceful wandering in your mind. The thin Martian atmosphere, mostly carbon dioxide, hosts dust devils that swirl like fleeting thoughts, lifting iron-rich soil to paint the skies in twilight hues. These storms, born from the planet's elliptical orbit and seasonal thaws, reveal layered sediments and craters that chronicle a history of floods and droughts, a geological diary waiting to be read. In the chill of Martian nights, temperatures plummet, condensing the air into frost that mirrors the hush before dawn, inviting us to ponder how such a world, once perhaps alive with waters, now rests in contemplative silence. Methane bursts detected sporadically from the surface suggest geological or biological sources, buried deep, fleeting plumes that dissipate like sighs, challenging us to imagine underground networks of aquifers percolating through fractured rock, sustained by leftover heat from Mars's formation, a persistent inner glow that defies the surface's aridity, much like the inner peace that persists through outer turmoil. Phobos and Deimos, its potato-shaped moons, likely captured asteroids, orbit so close that Phobos rises and sets twice daily, its grooves hinting at tidal stresses that may one day tear it apart into a ring, while Deimos drifts lazily, a faint silhouette against the stars, evoking the quiet companionship of distant thoughts in a meditative reverie. Valles Marineris, a chasm system longer than the U.S. continent, may have formed from crustal cracking as Mars cooled, its walls layered with sulfates from evaporated seas, a scar that tells of a planet's youthful vigor now mellowed into enduring quietude. Hellas Basin, the deepest impact crater in the solar system, cradles a thin, seasonal atmosphere denser there, fostering occasional mists that soften its vast floor. A basin born from a colossal strike that reshaped the planet's spin. Now a serene depression holding echoes of that ancient tumult like a bowl, catching the last light of day. Tharsis Bulge, a massive volcanic province, uplifted the crust to form the canyons nearby. Its calderas like emptied hearts of giants where ancient magmas rose to sculpt the highlands, leaving a legacy of elevation that alters wind patterns even today. A subtle topography that guides the planet's sparse winds like veins directing a faint pulse. Acidalia planitia, a northern lowlands basin, may conceal ancient lake sediments beneath dust, where phyllosilicates formed in wetter times, now buried under layers that preserve the chemical signatures of a bygone hydrological cycle. A hidden archive that speaks to Mars's capacity for quiet preservation, much as forgotten letters hold the essence of past conversations in the drawer of memory. Noachis Terra, a southern highland pocked with ancient craters, bears the scars of the late heavy bombardment, its eroded rims and basin floors hinting at prolonged water activity that carved valleys and deposited clays, a rugged testament to a time when Mars might have supported fleeting ecosystems, now etched into a landscape that invites serene exploration under the thin, rosy sky. Arabia Terra, a vast plateau riddled with outflow channels, suggests episodic flooding from subsurface reservoirs, where water burst forth in ancient deluges, now dry and windswept, a testament to Mars's capacity for sudden release followed by prolonged calm. much like the way emotions ebb after a storm of feeling. Syrtis Major, a dark, shield-like feature, stands as an ancient volcanic highland, its subdued relief from erosion by wind and water, a quiet monument to Mars's early igneous vigor, where basaltic lavas once spread widely, now patinaed by iron oxides into a contemplative shade that absorbs the faint sunlight like a sage absorbing wisdom from the ages. Elysium Planitia, another volcanic province, hosts low shields and fissures that hint at prolonged effusive activity, a secondary hearth where mantle plumes may have lingered longer than elsewhere, fostering a landscape of gentle domes that rise like breaths from the planet's cooling interior, inviting us to envision how such quiet outpourings could have sustained fleeting oases in Mars's red expanse. Beyond Mars, the asteroid belt stretches like a scattered archipelago in our solar ocean, remnants of worlds that never fully formed. Here, rocky bodies tumble in eternal dance, holding metals and iron forged in the sun's early fires. The world has yet to mine their deepest secrets, perhaps water-rich asteroids that delivered life's building blocks to Earth, or rare elements that could power humanity's next leap. Ceres, the belt's dwarf guardian, hides bright spots of salt and ice, hinting at subsurface brines that bubble like hidden springs. These fragments remind us of the universe's patient creation, piecing together matter over eons, much like dreams assembling in the quiet of night. Breathe in this vastness, letting it expand your sense of peace. Vesta, another sentinel, bears a massive crater at its south pole, exposing mantle rocks that tell of differentiation. How these bodies separated into core, mantle, and crust, much like the planets themselves. Impacts here have ejected meteorites to Earth, carrying stories of the solar system's violent youth, when collisions were as common as breaths in a storm. Yet in their current orbit, these asteroids glide serenely, guardians of primordial chemistry, where organic compounds simmer in the dark, precursors to the complexity we call life. Psyche, a metallic world rich in iron and nickel, may represent a stripped core of a protoplanet, its surface a relic of cataclysm, offering insights into planetary interiors without the veil of crust. As these bodies orbit between 2 and 4 astronomical units, their eccentric paths influenced by Jupiter's gravity create gaps like the Kirkwood ones, empty lanes where resonances clear the way, a cosmic sorting that echoes how thoughts organize in the mind's quiet spaces, leaving room for clarity. Bennu, sampled by spacecraft, reveals hydrated minerals and organics from the early solar system, its rubble pile structure held by weak gravity, spinning slowly as it sheds particles, a fragile archive tumbling through space like a leaf in a gentle current. Hygeia, the belt's 4th largest, shows signs of past cryovolcanism, with bright facets possibly from water ice eruptions, suggesting even these fragments once harbored internal fluidity, now crystallized into silent forms that drift in perpetual orbit. Pallas, tilted in its spin, bears a family of collisional fragments orbiting nearby, a dispersed clan that traces a breakup event billions of years ago, their paths intertwining like threads in a forgotten tapestry, preserving the memory of unity and separation. Interamnia, another carbonaceous body, rotates retrograde, its irregular shape hinting at ancient impacts that altered its spin, a world that carries the scars of the belt's formative chaos in its form, gliding through the asteroid sea with a quiet asymmetry that speaks to the resilience of form amid disruption. Eunomia family asteroids, stemming from a single large collision, populate the inner belt, their spectral varieties revealing differentiated parentage, a shattered lineage that now orbits as a subtle constellation, reminding us how even fragmentation can lead to widespread, harmonious distribution in the cosmic flow. Themis family, another collisional remnant, includes carbonaceous members with possible ice exposures, where impacts may have liberated volatiles that briefly formed cometary tails, a fleeting display of hidden moisture in these dry wanderers, evoking the way buried emotions surface in moments of quiet revelation. Eos family, with its bright basaltic members, hints at a differentiated parent that melted internally, its fragments now scattered like embers from a cooling fire, carrying the warmth of ancient processes into the belt's chill. Flora family, the most populous clan, orbits near the inner edge, their S-type composition suggesting a common origin in a disrupted protoplanet. A vast kinship that fills the space with subtle gravitational harmonies, much like the unseen ties that bind distant acquaintances in the quiet weave of community. Nisopolana family, another inner group, shows primitive compositions with possible organics, their orbits perturbed by Jupiter to occasionally cross Earth's path, delivering carbonaceous gifts that enrich our meteorite collections. A gentle reminder of how the belt's wanderers bridge the inner and outer solar realms in their slow, inexorable drift. Jupiter, the giant of our system, swells into view like a swirling storm of breath. Its great red spot a tempest older than human history, raging yet contained. This gas giant, with its dozens of moons, guards secrets in its turbulent clouds, perhaps storms that generate lightning storms vast enough to light distant worlds. But the true mysteries lie with Europa, one of its icy moons, where a global ocean sloshes beneath a cracked shell, warmed by Jupiter's tidal pull. Scientists believe this hidden sea, deeper than all Earth's oceans combined, could harbor life, simple organisms drifting in the dark, undiscovered sentinels of biology's reach. Imagine Europa as the subconscious mind, vast and unexplored, its waters a metaphor for the depths we all carry. Let Jupiter's majestic presence envelop you, a protective giant fostering calm. Ganymede, the largest moon, possesses its own magnetic field, a rare trait generated by a subsurface saltwater ocean interacting with Jupiter's powerful one, creating auroras that shimmer unseen. Callisto, pockmarked with ancient craters, may hold a deep ocean too, insulated by thick ice, where the slow drip of time has preserved conditions stable for billions of years. Jupiter's gravity sculpts these worlds, stretching and kneading their interiors like dough under a baker's hands, releasing heat that sustains hidden warmth. A cosmic hearth in the cold expanse. Io, in contrast, dances closest, its surface a canvas of active volcanoes spewing sulfur plumes, driven by tidal friction that heats it like a perpetual forge, painting the moon in yellows and reds, a vivid reminder of how proximity breeds intensity. Yet even here, the ejecta forms a thin atmosphere that trails like a comet's tail, dispersing into Jupiter's magnetosphere. This system's complexity, with irregular moons captured from afar, hints at Jupiter's role as a gravitational shepherd, herding planetesimals during formation and perhaps ejecting others to wander the outer solar system, shaping the architecture we inhabit today. The planet's banded clouds, zones of ammonia ice and deeper water clouds, flow in alternating directions, driven by deep-seated convection that rises and sinks like breaths in a vast lung, while radio emissions from its auroral ovals sing across space, detected by earthly antennas as whispers of charged particles trapped in magnetic lines. Amalthea, a reddish inner moon, may be coated in sulfur from Io's volcanoes, orbiting so swiftly it completes a loop in 12 hours, a close companion that reflects Jupiter's influence in its captured, irregular form, much like how close relationships shape our own quiet evolutions. The Shoemaker-Levy 9 comet's impact in 1994 scarred Jupiter's atmosphere with dark plumes, a rare glimpse of surface renewal, where fragments plunged into the southern hemisphere, stirring ammonia clouds into fresh patterns that lingered for months, a cosmic healing that underscores the planet's resilient atmosphere, absorbing violence into gradual dissipation. Oval Ba, a smaller storm that merged with the Great Red Spot in recent years, demonstrates how these atmospheric features evolve, colliding and blending like ideas in a contemplative mind, their colors shifting from white to red through chemical reactions with stratospheric compounds, a living canvas where Jupiter's depths reveal themselves in slow, majestic transformations. Juno spacecraft data unveils deep ammonia plumes rising from below the clouds, hinting at cyclonic vortices that penetrate the interior. A vertical exchange that mixes the planet's layers like a slow stir in a vast cauldron, fostering the dynamic weather we observe from afar, a reminder of how hidden currents drive the surface calm. The planet's deep interior, probed indirectly through gravity measurements, suggests a dilute core of heavy elements blended with hydrogen, a fuzzy boundary where metallic hydrogen transitions to molecular forms, a layered fluidity that generates the immense magnetic dynamo, much like how blended experiences form the core of our inner strength, sustaining the outward poise. Lightning within Jupiter's clouds, inferred from radio bursts, may charge particles that influence the planet's ionosphere, a subtle electrification that links atmospheric layers in an electric whisper, evoking the quiet charge of anticipation before profound realization. The planet's zonal jets, whipping eastward at hundreds of kilometers per hour, create Rossby waves that propagate disturbances, a fluid dynamics that maintains the banded appearance, much like the steady currents of habit that underpin the flow of daily life, allowing for graceful variations without chaos. The magnetosphere's ioplasma torus, a donut of ionized sulfur and oxygen encircling the planet, glows in ultraviolet from electron impacts, a radiant ring fed by volcanic ejecta that interacts with Jupiter's field, creating a perpetual auroral display along flux tubes, much like an inner light sustaining an outer glow in the quiet harmony of being. Saturn follows, adorned with rings like ethereal halos, composed of ice and rock particles that sparkle in the sunlight. These rings, thinner than a whisper, hold secrets of their birth, perhaps shattered moons caught in Saturn's gravity, orbiting like thoughts in a meditative state. Enceladus, a tiny moon, ejects plumes of water vapor from its south pole, revealing a subsurface ocean rich with organics. The world hasn't yet plumbed these geysers fully, but they suggest hydrothermal activity, much like Earth's vents, where life might quietly thrive. Saturn's system is a symphony of gravity's dance, rings fading into space like breaths dissolving into air. Feel the ring's delicate beauty mirroring your own relaxation, light and unburdened. Titan, Saturn's largest moon, wraps itself in a thick nitrogen atmosphere, thicker than Earth's, with methane rivers carving channels across hydrocarbon dunes, worlds within worlds, where liquid ethane pools under a hazy sky. This moon's organic haze, born from sunlight breaking apart methane, rains down as tholins, complex molecules that could be steps toward prebiotic chemistry. As Cassini revealed, Titan's surface hosts lakes that ebb and flow with seasons, a slow, rhythmic cycle akin to the heartbeat of sleep, where chemistry unfolds in languid time. Rhea, another moon, may possess its own tenuous ring system, particles orbiting in a diffuse band, a subtle echo of the planet's grandeur, while Iapetus displays two-toned hemispheres, one bright, one dark, like a world divided by light and shadow, its leading side coated in reddish dust from external sources, perhaps Phoebe's debris. Saturn's hexagonal storm at the North Pole, a persistent wave pattern etched by winds, defies simple explanation, a geometric wonder that stabilizes like a crystal in solution, inviting us to see the universe's penchant for elegant order amid chaos. Mimas, with its massive Herschel crater, resembles the Death Star from Tales, yet its core may be differentiated, harboring a small ocean warmed by tidal flexing, a hidden fluidity in a frozen shell that speaks to the persistence of motion in apparent stillness. Dione's trailing hemisphere bears wispy terrains of bright ice cliffs, possibly from tectonic extension, while Tethys hosts the massive Ithaca Chasma, a canyon girdling half the moon, born from internal stresses. These features painting Saturn's retinue as a family of worlds, each bearing unique imprints of gravitational dialogue. Hyperion, tumbling chaotically, shows a spongy surface pitted with craters that lack rays, its low density suggesting a porous interior, orbiting in a non-Keplerian path influenced by resonances, erratic dancer in the system that embodies the unpredictable grace of free motion within bounds. Pan, a shepherd moon embedded in the Enki Gap, maintains the ring's structure by gravitational nudges. Its walnut shape, from accumulated ring material, a tiny guardian that orbits inside the rings, herding particles with gentle tugs, much like how small habits shape the flow of larger routines in the quiet rhythm of existence. Atlas, another ring shepherd, leads the A-ring's edge, its elongated form collecting moonlets that enhance its gravitational influence, a delicate partnership that keeps the ring's boundaries sharp, evoking the way minor influences define the contours of broader patterns in life's unhurried progression. The ring's Cassini division, a wide gap sculpted by Mimas's orbital resonance, demonstrates how gravitational harmonies create voids in the particle stream, a cleared space that highlights the interplay of forces, much like pauses in a melody allow the notes to resonate more deeply in the listener's mind. Propellers, small disturbances in the rings from embedded moonlets, create feather-like patterns that reveal hidden masses, subtle signatures of life within the disk, like faint ripples on a still pond betraying the presence of unseen currents below. The F-ring's braided structure, influenced by Prometheus's gravitational pokes, twists into transient knots, a dynamic filigree that evolves over months, illustrating how even in a seemingly static system, gentle perturbations weave intricate, ever-changing designs, much like the subtle influences that enrich the fabric of personal growth. The ring's vertical thickness, varying with particle size, allows for occasional spokes from electromagnetic charging, ethereal radial features that fan out like whispers caught in a breeze, adding a layer of transient artistry to the system's enduring poise. Uranus and Neptune, the ice giants, reside in the outer realms, tilted and mysterious, their atmospheres of hydrogen and helium hiding diamond rains that fall like cosmic jewels. Uranus, tipped on its side, spins in a peculiar waltz, its moons orbiting in unexpected paths, secrets of an ancient collision that reshaped it. Neptune's winds howl faster than sound, yet its moon Triton retrogrades like a dream defying logic, spewing nitrogen geysers from icy depths. Undiscovered here are vast subsurface oceans of water-ammonia mixes, potentially cradling exotic life forms adapted to the cold. These distant worlds evoke infinity, their blues blending into the void, like the endless horizon of sleep. Let their quiet isolation draw you inward toward rest. Uranus's faint rings, dark with organic dust, whisper of a system disrupted long ago, while its atmosphere hosts methane that paints it azure, absorbing red light to leave the blue of distant dawns. Neptune's great dark spot, once observed, has vanished and reformed, a fleeting storm in an ocean of gas, reminding us how even giants yield to change. Miranda, one of Uranus's moons, bears cliffs taller than Everest, carved by tidal forces that fractured it like a dream half-remembered, now reassembling in gravitational harmony. Ariel and Umbriel orbit nearby, their surfaces scarred by cryovolcanism, eruptions of water and ammonia that froze into bright flows, suggesting past activity driven by internal warmth from radioactive decay. Neptune's Proteus, irregular and cratered, tumbles in orbit, a captured Kuiper object perhaps, while Nereid follows an eccentric path hinting at violent origins. These ice giants, formed farther out and migrated inward, bear mantles of water, methane, and ammonia ices under rocky cores, their interiors layered like an onion, compressing gases into exotic states of matter that challenge our understanding of planetary diversity. Uranus's seasons, lasting 21 years each due to its 84-year orbit, bring extreme tilts where poles bask in endless summer light, fostering asymmetric cloud bands that evolve slowly, while Neptune's internal heat, greater than solar input, drives its tempests, an inner fire that sustains dynamism in the outer chill, much like the warmth of memory enduring in the cool of evening. Titania, Uranus's largest moon, shows fault scarps and possible cryovolcanoes. Its surface a mosaic of impact basins filled with resurfaced plains, while Oberon bears dark craters that trap ejecta, creating rayless pits, a subtle artistry of retention in the void. Larissa, one of Neptune's inner moons, orbits perilously close, its irregular shape suggesting a captured body, grazing the planet's faint ring arcs, a delicate balance that highlights the ice giant's subtle gravitational web, weaving small worlds into its outer symphony. Voyager 2's flyby revealed Uranus's ring spokes, transient features from electromagnetic interactions, radial shadows that vanish and reappear, a dynamic interplay between plasma and dust that adds mystery to the faint system, like fleeting inspirations crossing the mind's calm expanse. Halimede, a distant irregular moon of Neptune, orbits retrograde in a clustered path with others, likely captured from the Kuiper belt, its faint trail a testament to the ice giant's reach, drawing in wanderers to form an extended family in the outer shadows, where their slow revolutions mark the passage of deep time with serene indifference. Naiad, Neptune's innermost moon, skims the faint Adam's ring, its orbit decaying slowly from tidal forces, a close companion that embodies the gentle pull of inevitability, much like the soft draw of evening toward night. Galatea, another inner moon, herds the ring's arcs through resonance, creating clumped densities that persist like gathered thoughts in a wandering mind, a gravitational artistry that maintains order in the scattered outer realm. The moon's prograde orbits, aligned with the planet's spins despite the extremes, suggest a shared formation disk disrupted by impacts, a resilient alignment that speaks to the enduring patterns beneath surface oddities, much like the steady core of identity that persists through life's upheavals. Uranus's epsilon ring, the outermost and densest, may contain larger chunks that create its opacity, a shadowy band that orbits inclined to the planet's equator, a quiet defiance of alignment that hints at post-formation scattering events, weaving a tale of gentle disruption in the system's outer harmony. Now, we turn to the Kuiper belt and beyond, a realm of icy wanderers where Pluto reigns as a dwarf prince, its heart-shaped plain a testament to frozen volatiles. New Horizons revealed mountains of water ice, but the secrets persist. Perhaps a thin atmosphere that cycles with its orbit, or subsurface oceans kept liquid by radioactive warmth. The Oort cloud encircles all, a spherical shell of comets like distant memories, occasionally perturbed by passing stars to send icy visitors our way, harbingers of the solar system's birth. These comets carry pristine materials from 4.6 billion years ago, organic molecules that seeded life, undiscovered in their full diversity. The solar system, then, is a breathing archive, its outer edges fading into the galaxy's embrace, where time stretches like an eternal dream. Eris, another Kuiper denizen, rivals Pluto in mass, its icy surface reflecting sunlight dimly, hinting at a nitrogen frost that sublimes into a temporary veil. Haumea, elongated like a rugby ball, spins rapidly, shedding ring material from ancient collisions, a reminder of the chaotic sculpting that birthed these fringes. In the Kuiper's scattered disk, objects like Sedna follow eccentric paths, reaching out to nearly 1,000 astronomical units, guardians of the solar system's extended family, where the sun's light weakens to a mere star among many. Makemake, with its methane-rich surface, hosts possible cryovolcanic features, dark patches that may be tholins from atmospheric escape, while Quaoar dances with a thin ring and distant moon, blending traits of dwarf and classical Kuiper objects. These bodies, leftovers from the solar nebula's outer disk, preserve the chill of formation, their surfaces evolving slowly under micrometeorite impacts and solar ultraviolet, a glacial pace that mirrors the unhurried deepening of sleep. Orcus, resonant with Neptune, bears a polar cap of methane frost that seasons with its orbit, while Gongong's reddish hue suggests fresh resurfacing by volatiles, hinting at active geology in these remote realms, where tidal interactions with larger bodies may stir faint warmth, fostering thin exospheres that whisper of transient atmospheres. Varuna, with its elongated shape, rotates swiftly, perhaps from a past merger, its spectrum rich in complex organics, a relic that carries the scent of the solar system's dawn, drifting in orbits that loop far beyond the planet's reach. Salacia, a binary dwarf, shares its path with a moon of similar size, their mutual tide locking them face to face, a quiet partnership in the outer dark that evokes the steadfast bonds formed in isolation, their combined gravity holding a thin ring of debris like a shared halo. 2007 or 10, or Gongong's kin in naming, shows a reddish tint from tholins, its irregular moon suggesting a captured origin, orbiting in the scattered disk where Neptune's migrations scattered these icy sentinels, a dispersed family holding the outer system's fragile equilibrium, much like scattered recollections that nonetheless form a cohesive inner narrative. 2014 Antwenine, or Arakoth, a contact binary visited by New Horizons, preserves its peanut shape from gentle coalescence, its reddish surface rich in methanol ices, a pristine snapshot of planetesimal formation where particles stuck softly in the nebula's chill, evoking the way disparate thoughts merge into unified dreams without collision's harshness. Sedna's perihelion, far beyond Neptune, brings it into faint sunlight every 11,000 years, its surface possibly layered with tholins from cosmic ray irradiation, a slow transformation that colors these distant travelers, much like the gradual tinting of memories over long silences. 2012 VP1113, another inner Oort candidate, orbits in eerie solitude, its path suggesting a larger unseen perturber shaping the scattered disk, a subtle gravitational ghost that invites contemplation of hidden influences guiding the outer reaches. The Hills Cloud, a theoretical inner extension of the Oort, may supply long-period comets, bridging the Kuiper and outer shell in a continuous reservoir of ices, a vast, unseen mantle that envelops the system in quiet anticipation of perturbation. Detached objects like Sedna, with aphelia beyond 500 AU, hint at an extended scattered disk influenced by early giant planet instabilities, a far-flung frontier where the solar system's influence wanes into interstellar space, much like the fading echo of a story told across vast distances. Yet, woven through these worlds are the grander secrets. Black holes lurking at galactic centers, pulling matter into infinite density. Their event horizons like the edge of sleep from which nothing returns. Our Milky Way harbors one at its heart, Sagittarius A, a quiet giant influencing the star's slow whirl. As telescopes like the Event Horizon have imaged its shadow, we glimpse accretion disks of superheated gas spiraling inward, glowing with the fury of captured light. These voids teach us of gravity's ultimate embrace, where time dilates to a standstill, a profound stillness akin to the pause between breaths in deep meditation. Jets of plasma sometimes erupt from their poles, carving through space at relativistic speeds, powered by twisted magnetic fields that accelerate particles across cosmic distances, illuminating the role of these behemoths in galaxy evolution. Intermediate mass black holes, rarer and elusive, may lurk in globular clusters formed from stellar mergers, their growth seeding the supermassive ones we know. Primordial black holes, hypothetical relics from the early universe, could dot the halo, their evaporation via Hawking radiation a faint theoretical hum. Stellar mass black holes, born from collapsed stars, wander our galaxy, some paired with companions that feed them gas, flaring as X-ray binaries that pulse with orbital rhythms, silent predators in the stellar crowd. Ultraluminous X-ray sources, possibly intermediate black holes in distant galaxies, outshine expectations, their disks glowing with extreme accretion efficiency. Quasar feedback, where outflows from active nuclei quench star formation, regulates galaxy growth, a self-limiting process that allows balanced evolution across cosmic scales. Supermassive black hole binaries in merging galaxies emit gravitational waves detectable by pulsar arrays, their in-spiral a slow dance toward coalescence. Dormant black holes, starved of fuel, lurk undetected, their presence inferred from stellar dynamics in cluster cores. Recoiling black holes kicked by asymmetric mergers may wander galaxies, their high velocities a legacy of gravitational recoil. Supermassive black hole seeds, perhaps direct collapse from massive gas clouds in the early universe, grew rapidly to anchor galaxies, a foundational growth that set the stage for stellar nurseries. Intermediate black hole candidates in globular clusters like 47 Tucanae, inferred from X-ray sources, suggest runaway mergers in dense environments, quiet accumulators that bridge stellar and supermassive scales. Naked singularities, theoretical endpoints without horizons, challenge our understanding if cosmic censorship fails, points of infinite curiosity where physics unravels like a dream without boundaries. The Penrose process, extracting energy from rotating black holes by flinging particles from the ergosphere, powers theoretical jets, a clever theft from the void's spin that echoes how we draw sustenance from quiet depths. Ergoregion instabilities, waves amplifying in the spinning region, could seed early accretion, a subtle vibration that awakens the black hole's influence on surrounding space. Nebulae, birthplaces of stars, bloom like cosmic flowers. Orion's Nebula, a stellar nursery where gas clouds collapse under gravity's gentle insistence, forging new suns. Within these cradles, protostars accrete dust in protoplanetary disks, much like raindrops gathering in a pond, eventually birthing systems like our own, planets coalescing from the debris of creation. Picture the Eagle Nebula's pillars of creation, towering columns of interstellar dust sculpted by ultraviolet winds from young stars, evaporating slowly over millennia. A patient erosion that reveals the birth of light from darkness. The Crab Nebula, remnant of a supernova observed in 1054, pulses with a central neutron star spinning 30 times a second, its synchrotron radiation weaving a tapestry of radio waves and X-rays, a stellar corpse that continues to energize its surroundings long after the explosion's roar. Planetary nebulae, like the Ring Nebula, expand from dying sun-like stars, shells of ionized gas glowing in forbidden lines, their shapes sculpted by stellar winds into rings and butterflies. A final exhale before fading to white dwarf embers. Reflection nebulae, such as those around Pleiades, scatter blue light from young clusters, veils of dust that cradle fledgling stars, soft as the hush of gathering twilight. Emission nebulae, ionized by Hotto stars, glow in reds and greens from hydrogen and oxygen, vast ionized regions spanning light years, where feedback from massive stars carves bubbles that propel the next generation of formation. Dark nebulae, like the Horsehead, absorb light to stand as silhouettes against glowing backdrops, dense cores on the verge of collapse, quiet harbingers of stellar birth hidden in shadow. Barnard 68, a Bok globule in Ophiuchus, exemplifies this opacity, its sharp edges outlining a future star's cradle, where gravity's patient pull gathers mass in isolation, much like the slow accumulation of resolve in moments of stillness. The Trifid Nebula, split by dark lanes, blends emission and reflection regions, a tripartite scene where young stars illuminate the birth of siblings, a harmonious division that speaks to the interconnectedness of creation's early stages. The Lagoon Nebula, a bright emission cloud, hosts open clusters that stir the gas into star-forming waves, a serene lagoon where stellar youth ripples outward like gentle waves on a cosmic shore. The Cat's Eye Nebula, a complex planetary shell, reveals multiple ejections over time, layered like an onion of a star's final breaths, each envelope a chapter in its quiet demise, inviting us to see how even endings unfold in intricate, beautiful sequences. The Helix Nebula, dubbed the Eye of God, shows cometary knots in its outer shell, icy globules evaporating under central starlight, a poignant gaze into the star's farewell, where fragile forms dissolve into the nebula's glowing embrace. Time here is relative, bending near massive objects as Einstein described a river that flows differently for each observer. On a neutron star, a teaspoon of matter weighs as much as a mountain, time ticking slower in its intense gravity, where pulses from spinning beacons, pulsars, serve as cosmic clocks, beaming radio waves like lighthouses in the night. White dwarfs, cooled remnants of sun-like stars, slowly crystallize their interiors into diamond lattices under degenerate pressure, a serene end to stellar life where gravity halts fusion, leaving a quiet ember. Magnetars, with their ultra-strong fields, occasionally glitch, sudden spin-ups that release energy in bursts, disrupting their timing like a hiccup in the cosmic rhythm. Binary pulsars orbiting companions test general relativity through orbital decay from gravitational waves, their precision confirming predictions to exquisite degrees. Millisecond pulsars, spun up by accretion from companions, tick with extraordinary stability, serving as galactic GPS for mapping the Milky Way's structure. Recycled pulsars and globular clusters, dense environments of stellar remnants, pulse amid a crowded field, their signals navigating the gravitational maze. Isolated pulsars, drifting through the halo, cool gradually, their spin-down luminosity fading like embers in the interstellar night. Yet their persistent beams cut through the void, a testament to endurance in solitude. Gamma-ray pulsars, detected by Fermi, reveal emission from magnetospheres where accelerated electrons radiate, mapping field geometries in high-energy light. Accretion-powered pulsars in high-mass binaries spin down under propeller effects when material can't attach, a rhythmic interplay that modulates their output like breaths held and released in contemplation. The glitch phenomenon in young pulsars, sudden slowdowns from superfluid vortex spinning, releases in irregular bursts, an internal readjustment that echoes the occasional pauses in a steady meditation, where the mind recalibrates its focus. Precession in binary pulsars, like the Hulse-Taylor system, wobbles their beams, adding nuance to timing signals, a gentle nod that refines our measure of spacetime's curve. Matter, from quarks to quasars, dances in quantum whispers. The universe's infinite expanse, a meditation on existence itself. Dark matter, invisible threads weaving through galaxies, outmasses the visible by 5 to 1, inferred from the way stars orbit too swiftly without flying apart. A hidden scaffold holding the cosmic web intact. Candidates like WIMPs or axions elude detection, yet their gravitational pull clusters matter into filaments spanning billions of light years, a subtle architecture that birthed our galaxy's spiral form. Sterile neutrinos, another prospect, might decay into light, explaining gamma-ray excesses from the galactic center. Self-interacting dark matter could form dense cores in dwarfs, easing cusp core tensions in simulations. Fuzzy dark matter, ultralight bosons forming waves, suppresses small-scale structure, smoothing halos like a gentle tide. Warm dark matter, lighter particles, allows for more clumpy distributions, fitting observations of dwarf galaxies as substructure hosts. Mirror dark matter, a parallel sector interacting gravitationally, could explain direct detection anomalies, a shadowed twin to our visible realm. And dark energy, the accelerating force expanding the universe, pushes galaxies apart faster than light can bridge, turning the cosmos into an ever-widening breath, exhaling into greater vastness. This phantom energy, comprising 68% of the universe's budget, may arise from vacuum fluctuations or modified gravity, driving the scale factor in Einstein's equations to exponential growth. A cosmic inflation that isolates galaxy groups in an increasingly lonely void. Quintessence fields, dynamic forms of dark energy, could vary over time, easing tensions in expansion measurements and hinting at a universe that breathes not just outward, but with subtle pulses. Phantom dark energy, if it crosses the phantom divide, might lead to a big rip, tearing structures apart in a final unraveling, though current data favors a gentle fade. Holographic dark energy, bounded by the cosmic horizon, ties expansion to information limits, a philosophical link between geometry and the universe's content. K-essence models, with kinetic-driven fields, offer alternatives where sound speeds vary, potentially resolving small-scale cosmic issues with fluid-like behavior. Interacting dark energy, coupled to dark matter, allows energy transfer that alters growth rates, smoothing discrepancies in structure formation observations. Chameleon dark energy, screening in dense regions, evades local tests while accelerating on large scales, an adaptive force that hides in plain sight, much like intuition that surfaces only in expansive moments. Coupled quintessence, where dark energy interacts with baryons, could explain accelerated expansion without fine-tuning, a harmonious linkage that binds the universe's components in subtle dialogue. Growing neutrino quintessence, where light neutrinos gain mass from scalar fields, reconciles oscillation data with cosmological constraints, a gentle evolution that ties particle physics to the cosmos's large-scale breadth. Disformal couplings in dark energy models, warping distances between matter types, might resolve Hubble tension by altering light propagation, a subtle distortion that reframes our measure of cosmic expansion like a lens softening the view of distant horizons. Galaxies spiral outward, islands in the void, our solar system but a speck in the Andromeda's future merger, a billion-year embrace that will light the sky in a cascade of new stars. Within the Milky Way's spiral arms, supernovae forge heavy elements in their explosive deaths, scattering gold and iron like stardust across the interstellar medium. The building blocks returned to the cycle. Type Ia supernovae, from white dwarfs reaching the Chandrasekhar limit, serve as standard candles measuring cosmic distances, their predictable brightness revealing the universe's expansion history. Core collapse supernovae, from massive stars imploding, drive galactic winds that enrich the intergalactic medium, fueling future generations of stars. Pair instability supernovae, in metal-poor massive stars, obliterate without remnants, their light curves distinct markers of early universe explosions. Hypernovae, extreme variants, launch jets that drill through stellar envelopes, producing gamma-ray bursts as cosmic drills. Electron capture supernovae in intermediate mass stars, under white dwarf-like conditions, offer fainter explosions that seed the medium gently. Calcium-rich transients, from helium shell detonations in white dwarfs, enrich the outskirts of galaxies with light metals, a subtle contribution to chemical gradients. Quasars, in distant youth, shine from supermassive black holes devouring gas, outshining entire galaxies, beacons from when the universe was a third its current age. These active galactic nuclei, with broad emission lines from orbiting gas, trace the growth of monsters that seeded early structure, their feedback regulating star formation like a thermostat in the cosmic oven. Blazars, quasars aimed at us. Beam gamma rays from relativistic jets, probing the extragalactic background light and the universe's opacity to high energies. Radio galaxies, with lobes inflated by jets, span megaparsecs, their synchrotron bubbles relics of past activity that shape cluster environments. Seyfert galaxies, milder AGN, host active cores that ionize surrounding gas, their spectra revealing fast outflows that quench starbirth in host disks. Liners, low ionization regions, may stem from less active black holes or stellar processes, blurring lines between galactic heart and periphery. Starburst galaxies like M82 expel molecular gas in superwinds from intense star formation, carving outflows that enrich the circumgalactic medium, a violent yet creative phase in galactic life. Ultraluminous infrared galaxies, shrouded in dust, hide quasar activity behind starburst veils, their energy budgets revealing dual engines of growth. Lenticular galaxies, transitional forms between spirals and ellipticals, host central bulges with fading disks, quiet sentinels where star formation wanes into stellar aging, much like the gradual settling of a life into contemplative maturity. Dwarf spheroidal galaxies, satellites of the Milky Way like fornax, hold ancient stars with low metallicity, quiet archives of early accretion events, their dark matter halos dwarfing the visible light, evoking the profound stillness of overlooked wisdom in simple forms. In this tapestry, exoplanets orbit alien suns, hot Jupiters migrating inward, super-Earths with diamond rains, or ocean worlds shrouded in steam, each a secret unveiling the diversity of formation, from pebble accretion in disks to capture of wandering giants. The TRAPPIST-1 system, with 7 Earth-sized worlds in resonance, dances around a cool red dwarf, their habitable zones overlapping in perpetual twilight where tidal locking might create eternal dawns on one side. Proxima Centauri b, orbiting the nearest star, receives Earth-like insolation but faces stellar flares that could strip its atmosphere, a test of habitability in flare-prone systems. Lava worlds like 55 Cancri e, tidally locked with molten day-sides, evaporate atmospheres into glowing tails, while circumbinary planets and Kepler binaries orbit dual stars, their stable zones a delicate balance of dual gravities. Rogue planets, ejected from their systems, drift alone, warmed perhaps by internal heat, silent nomads in the galactic sea, numbering in the trillions, their atmospheres stripped or retained in frozen isolation. Some may host subsurface oceans, heated by tidal remnants or radioactivity, oases in the interstellar dark where life could ponder a starless sky. Free-floating planets detected via microlensing, briefly amplifying distant stars' light, reveal masses rivaling Jupiter's, hinting at ejected giants that roam freely, unbound yet part of the galaxy's quiet wanderers. Mini-Neptunes, with hydrogen envelopes over rocky cores, populate the exoplanet census, their hazy atmospheres hiding interiors that blend ice giant traits with terrestrial solidity. Sub-Earths, smaller than our world, challenge formation models, perhaps eroded cores or failed giants, their detection pushing sensitivity limits to reveal the full spectrum of planetary masses. Hycean worlds, hydrogen-rich ocean planets, offer steamy atmospheres with potential biosignatures, expanding the search for life to envelop dominated bodies where water worlds thrive under thick gas layers. Temperate Jupiters, gas giants in habitable zones, may harbor moon systems with liquid water, nested habitats that multiply possibilities for emergence in stable orbits. Eyeball planets tidally locked with liquid pools on the day side present asymmetric climates where life might cluster at the terminator, a balanced fringe between heat and cold that mirrors the equilibrium sought in daily rhythms. Super-puff planets, low-density giants like Kepler 51d, float with extended atmospheres, their ethereal forms suggesting hydrogen-dominated envelopes that puff like clouds, fragile worlds where gravity yields to lightness in the dance of formation. The radius valley between super-Earths and mini-Neptunes, a gap in exoplanet sizes, may arise from photoevaporation stripping envelopes from smaller cores, an evolutionary call that shapes the observed distribution, much like natural selection pruning possibilities to favor resilient forms in the cosmic garden. Like an ocean's depths, the universe holds uncharted realms, wormholes theorized as shortcuts through space-time, folding the fabric like a sheet of paper, though stability eludes our equations. Traversable ones might require exotic matter with negative energy, a speculative bridge between stars, evoking the mind's leaps and dreams. Einstein-Rosen bridges, connecting distant points, could link black holes in entangled pairs, a quantum thread in the cosmic weave. Intra-universe wormholes, stabilized by cosmic strings, might allow travel without leaving our bubble, a philosophical shortcut through the infinite. Rotating wormholes, Kerr-like, could permit passage with less exotic matter, their throats twisting time into loops that challenge causality. Morris-Thorne metrics describe ideal traversable paths, with tunable parameters for safe passage, though quantum effects might collapse them, a delicate balance akin to holding a fragile thought. Thin-shell wormholes, constructed from exotic spheres, offer models where traversability depends on shell tension, a conceptual skin-bridging voids. Visser wormholes with variable geometry allow for dynamic throats that expand or contract, adapting to traveler needs in theoretical designs. Casimir wormholes, drawing energy from quantum vacuum fluctuations, propose a self-sustaining stability without bulk exotic matter, a whisper of possibility from the fabric of space itself. Brain-world wormholes embedded in higher dimensions might connect distant brains, a multidimensional pathway that reimagines connectivity beyond our four-dimensional confines. Traversable wormholes in anti-de Sitter space, stabilized by boundary conditions, offer holographic analogs for quantum information transfer, a bridge between gravity and quantum realms that hints at deeper unifications. Gravitational waves, ripples from merging black holes, wash across the cosmos detected as faint tremors in laser arms, echoes of cataclysmic dances billions of light-years away. LIGO signals, chirping from inspiraling binaries, confirm general relativity in extreme regimes, opening a new sense to astronomy where we hear the universe's mergers. Future detectors like LISA in space will catch supermassive mergers, mapping the early universe's growth. Pulsar timing arrays detect low-frequency waves from supermassive binaries, a chorus from the cosmic hum that resonates through our galaxy. Stochastic backgrounds from early black hole mergers fill the spectrum, a primordial noise that hints at the universe's turbulent infancy. Nanohertz waves from cosmic strings or phase transitions could imprint on these arrays, relics from the universe's first moments. Third-generation detectors like Einstein Telescope underground will probe intermediate masses, unveiling a richer waveform landscape. The cosmic microwave background, a fossil glow from the Big Bang, maps tiny fluctuations that seeded galaxy clusters, a warm afterimage of the universe's infancy, cooling to 2.7 Kelvin, like the hush after a symphony's end. Planck satellite data reveals polarization patterns from gravitational waves in the early universe, hints of inflation's violent stretch smoothing the cosmos, where quantum seeds grew into the vast hierarchies we observe. Baryon acoustic oscillations imprint scale on this background, frozen sound waves from the plasma epoch, measuring dark energy's influence over 13.8 billion years. The Sunyaev-Zeldovich effect, where hot gas in clusters scatters CMB photons, outlines distant structures invisible to light, a thermal echo-bridging epochs. Integrated Sachs-Wolf effect, CMB distortions from evolving potentials, traces dark energy's onset, a subtle gradient in the ancient light. Foreground subtraction reveals the CMB's power spectrum, peaks and troughs that encode the universe's composition, from baryons to relics of inflation. Lensing of the CMB by foreground structure adds secondary signals, reconstructing mass distributions across the sky, a gravitational lens on the universe's skeleton. Secondary anisotropies like the kinetic Sunyaev-Zeldovich from cluster motion map peculiar velocities, tracing large-scale flows in the cosmic web. The cosmic infrared background, a glow from early stars and galaxies, carries dust-reprocessed light, a faint veil that hints at the universe's first luminous epochs, where obscured mergers contributed to the diffuse infrared sea. The cosmic neutrino background, a relic sea of particles from the Big Bang, permeates space with near-zero temperature, ghostly travelers that decoupled early, influencing structure formation in subtle ways like an unseen undercurrent in the cosmic flow. The cosmic gravitational wave background, a hum from primordial sources, may encode inflation's tensor modes, a faint vibration that ties the universe's birth to its ongoing expansion, much like the subtle resonance of a distant memory lingering in the quiet mind. The cosmic radio background, a faint hiss from early black holes and star formation, awaits precise mapping, a low-frequency echo that could reveal the universe's first radio-loud epochs, where synchrotron from nascent jets filled the young cosmos with electromagnetic whispers. As our journey through these hidden wonders deepens, consider the multiverse's whisper, parallel realities branching from quantum choices, or bubble universes inflating eternally, each with its own laws of physics, a philosophical expanse where every possibility breathes. String theory posits extra dimensions curled small, vibrating to produce particles and forces, a symphony of 10 or 11 dimensions where our four unfold like a flower. Brain worlds, where our universe floats on higher dimensional membranes, might explain gravity's weakness leaking into the bulk while other forces confine. Eternal inflation spawns bubbles via quantum tunneling, each with varying constants, a froth of realities where ours is but one stable foam. Landscape of string vacua, 10 modelers, 500 possibilities, populates the multiverse with diverse physics, a vast repertoire from which observers sample. Many worlds' interpretation of quantum mechanics branches timelines at measurements, an ever-diverging tree where all outcomes coexist, a conceptual infinity that parallels the universe's expansive quiet. Boltzmann brains, hypothetical self-aware entities arising from fluctuations in de Sitter space, challenge anthropic reasoning, fleeting thoughts in the multiverse's eternal flux. Cyclic brain models, with collisions repeating across eons, propose a universe reborn from crunch to bang, a perpetual rhythm without singular origin. Yet in our corner, the solar system's undiscovered secrets, lost rings around ancient giants, hidden moons in the outer dark, or primordial chemistry in cometary hearts, invite us to dream of connection, of life not as rarity, but as inevitable bloom in the cosmic garden. Interstellar dust, drifting between stars, carries polycyclic aromatic hydrocarbons that absorb UV and re-emit infrared, organic scaffolds traveling the galaxy like seeds on the wind. Molecular clouds, Vast nurseries of hydrogen laced with CO and water ice collapse under their weight to form stars, their filaments channeling gas in magnetic streams, a sculpting hand guiding birth. Bach globules, dark silhouettes against bright nebulae, are collapsing cores birthing low-mass stars, cocoons of future light. Herbig-Haro objects, jets from young stars colliding with gas, create glowing knots that trace outflow dynamics, ephemeral fireworks in the stellar nursery. Protoplanetary disks around T Tauri stars, observed in infrared, show gaps from forming planets, shadows of worlds carving their paths early on. Transitional disks, with inner clearings from photoevaporation or giant planets, mark the end of accretion phases, a quiet clearing where new systems stabilize. Debris disks, like Vega's, glow with collisions of planetesimals, dusty belts that may host unseen planets, a lingering haze of formation's aftermath. Oort cloud comets, perturbed inward, deliver volatiles to inner worlds, a slow rain of ancient ices that refreshes planetary surfaces over eons. Magnetars, neutron stars with fields 1,000,000,000,000 times Earth's, flare with gamma rays from crust quakes, brief bursts that outshine the sun for moments, revealing the extremes of magnetic confinement. Soft gamma repeaters, their gentler kin, pulse rhythmically, mapping field decay over time. Anomalous X-ray pulsars, cousins in the magnetar family, accrete from companions to sustain their glow, blending isolation with subtle nourishment. Isolated neutron stars, cooling in the halo, emit faint thermal glows, relics detectable by their motion against the stars. The silence of space, profound and absolute, mirrors the quiet before sleep, where no sound travels, only light and gravity weaving their silent tale, a vacuum that amplifies the inner voice of wonder. Cosmic voids, immense bubbles empty of galaxies, expand with the universe, their scarcity of matter highlighting the web's filigree, philosophical expanses where dark energy dominates unchecked. Eridanus supervoid, a vast underdensity, may influence CMB cold spots, a shadow in the light that suggests large-scale inhomogeneities. Botus void, one of the largest, spans 330 million light-years, a near emptiness that challenges uniformity. Yet even here, faint galaxies lurk, reminding us that voids are relative in the grand weave. Local void, adjacent to our group, recedes slowly, a nearby emptiness that frames the Milky Way's position in the larger flow. Giant voids like the sculptor, shaping supercluster boundaries, influence cosmic expansion locally, subtle underdensities that pull the web into relief. The Lynx Cancer void, a colossal expanse, hosts sparse filaments that thread its emptiness, a reminder that even in vast nothings, faint connections persist like whispers in a quiet room. Giant arc voids, curved underdensities aligned with large-scale structures, hint at primordial fluctuations that shaped the universe's skeleton, empty bows that cradle the cosmic bowstring of matter. The giant grin, a proposed supervoid structure, spans across constellations, its emptiness a subtle indentation in the cosmic density, inviting us to ponder how such vast absences define the presence of all else, much like the spaces between words that give meaning to the narrative. Supervoid's integrated Sachs-Wolf effect on the CMB, a cold imprint from falling photons, refines our map of large-scale structure, a gentle dimming that echoes the universe's uneven breath. Expanding further, ponder the role of cosmic rays, high-energy protons from supernovae or active nuclei slamming into atmospheres to spark cascades of particles, influencing cloud formation and perhaps climate on habitable worlds. On Earth, they contribute to mutations driving evolution, a subtle rain of change from the stars. Ultra-high-energy cosmic rays exceeding the GZK limit puzzle us with origins in distant blazars, their paths deflected by magnetic fields like leaves in a breeze. Pierre Auger Observatory maps their arrival directions, hinting at extragalactic sources aligned with radio galaxies. IceCube detects high-energy neutrinos from cosmic accelerators, messengers that pierce the Earth, tracing rays to blazer flares. Anita experiments, balloon-borne, seek upward-going rays from beyond the horizon, probing exotic physics like Lorentz violations. KM3Net, underwater in the Mediterranean, extends neutrino detection to northern skies, complementing IceCube's southern view. Gamma-ray bursts, the universe's most luminous explosions, beam from collapsing stars or merging neutron stars, sterilizing planets in their path if aligned. Yet their afterglows reveal heavy element synthesis in neutron-rich environments. Short GRBs from mergers seed ERR process elements like gold in the cosmos, while long ones from collapsers enrich disks around young stars. Orphan afterglows, GRBs whose beams miss us, await discovery in radio surveys, filling in the isotropic sky. Kilonova remnants from mergers glowing in infrared trace heavy element factories across the sky. Fast radio bursts, millisecond flashes from distant galaxies, may arise from magnetar quakes or neutron star mergers, their dispersion measures mapping intergalactic gas. Repeating FRBs, localized to our galaxy, suggest young magnetars and supernova remnants, persistent signals that evolve over time. Localized FRBs like FRB 1211-2 with precise positions reveal host galaxies rich in star formation, tying bursts to young stellar environments. In galaxy clusters like Virgo, hot intracluster medium glows in X-rays, binding thousands of galaxies with gravity and pressure, while ram pressure stripping shears gas from spirals, quenching starbirth in a cosmic wind. Merging clusters like Bullet produce shock waves that accelerate particles. Their bow shocks a frontier of high-energy physics. Cool cores and clusters, where gas cools centrally, form stars at rates defying expectations, balanced by feedback from active nuclei. Able 1689, a massive lens, warps light into arcs, revealing dark matter distributions in the cluster's halo. The Perseus cluster, with its central black hole's bubbles, shows sound waves rippling through the gas at millions of degrees, a sonic landscape etched in X-ray images. Coma cluster, with its diffuse radio emission, hosts relic synchrotron from past mergers, faint echoes of turbulent history. The Hubble constant tension, discrepant measurements of expansion rate, hints at new physics, perhaps varying dark energy or modified gravity, challenging our standard model like a puzzle piece that doesn't quite fit. Early dark energy, a transient field in the universe's youth, could resolve CMB anomalies, smoothing the path from Big Bang to structure. HOZO-Ly-SAO lenses from quasars refine distances, bridging local and cosmic scales. ESH-ES Cepheids calibrate supernovae, while decibaryon oscillations probe late-time dynamics. Tensions in sigma-8, clustering amplitude, suggest evolving dark matter or baryonic feedback, refining our view of structure growth. Local volume surveys, like 60FGS, map peculiar velocities to constrain growth rates, weaving local motions into the cosmic tapestry. Exomoons around gas giants in other systems, inferred from transit timing variations, could host stable climates, expanding the habitable real estate beyond solitary planets. Systems like Kepler 1625b a candidate moon, orbit in habitable zones, their parent planets providing tidal warmth to icy surfaces. Earth analogs in habitable zones of G-type stars, like those from Kepler, promise rocky worlds with potential biosignatures, their spectra awaiting JWST scrutiny. TOI 700d, a promising candidate, receives sunlight akin to Earth's, its transit depth suggesting a terrestrial size, inviting visions of alien shores under similar skies. LHS 1140b, a super-Earth in the habitable zone, shows signs of a thick atmosphere, potentially retaining water in a temperate embrace. K2-18b, a mini-Neptune with water vapor hints, blurs lines between rocky and gaseous, its potential for subsurface habitability expanding our definitions. LTT-14-5ab, a nearby rocky world, orbits a red dwarf with possible tidal locking, its iron-rich surface a canvas for atmospheric retention studies. GJ1132b, a Venus-like world transiting a nearby star, offers a close-up for studying rocky exoplanet atmospheres, a mirror to our neighbor's veiled mysteries. Carbon planets, theorized around carbon-rich stars, might form diamond interiors under high pressure, exotic realms where geology takes on crystalline beauty. A philosophical reflection on how different compositions yield worlds of varied splendor. Venus-like worlds in the habitable zone, with runaway greenhouses, serve as cautionary tales for atmospheric evolution, their thick CO2 envelopes a lesson in feedback loops that can tip planets from temperate to infernal, much like unchecked thoughts can cloud the mind's serene clarity. As we weave these threads, the universe reveals itself as a grand narrative, matter condensing from quantum foam into atoms, then stars, planets, and perhaps minds that ponder their origins. The fine-tuning of constants, gravity's strength, electron mass, allows complexity to emerge, a philosophical nudge toward deeper questions of design or multiversal lottery. Anthropic principles suggest we observe a universe suited for observers, yet alternatives like cyclic models propose endless big bangs and crunches, a breathing cosmos without beginning. Ekpyrotic scenarios, brain collisions in higher dimensions, birth hot big bangs from cold contractions, a rhythmic cycle of renewal. Conformal cyclic cosmology, where the universe resets through infinite expansion, links ions via angular scales, a perpetual rebirth from faded embers. Loop quantum gravity, quantizing space itself, predicts a bounce from contraction to expansion, avoiding singularities in a discrete fabric. Asymptotic safety, where gravity becomes finite at high energies, offers a renormalizable path without new physics. Emergent gravity, arising from quantum entanglement, reimagines space-time as a holographic projection, a subtle weave from information's fabric. Yet in this expanse, our solar system's intimacy grounds us, its secrets a personal invitation to curiosity, unfolding like a story told in the stars' patient light. Panspermia, the seeding of life via comets or dust, ties our biology to the Kuiper's gifts, while extremophiles on Earth, tardigrades surviving vacuum, hint at life's portability across the void. The Drake equation, estimating communicative civilizations, balances stellar rates with habitability factors, a meditative tally that invites humility in our galactic solitude. Fermi paradox whispers of where others hide, perhaps in Dyson spheres cloaking stars or post-biological uploads in virtual realms, speculations that expand our sense of possible companionship in the infinite. Biosignatures like atmospheric oxygen or technosignatures such as laser pulses await detection, turning telescopes into ears for the cosmic conversation. In this vast dialogue, our solar system's undiscovered layers, from microbial realms in Martian brines to organic soups on Enceladus, remind us that discovery is an inner journey as much as outer, a gentle unfolding toward greater wonder. Astrobiology's search extends to Venusian clouds and Europa's depths, where extremal life might thrive in conditions mirroring Earth's fringes, fostering a sense of shared possibility across the solar sea. The unity of biochemistry, from amino acids in meteorites to proteins in our cells, suggests a common origin, a cosmic recipe distributed by impacts and winds, binding us to the stars in an unbroken chain. Convergent evolution, where eyes or wings arise independently, hints at universal principles guiding life's forms. A philosophical echo that life's patterns may be etched in the universe's laws themselves. Homochirality, the preference for left-handed amino acids, may stem from cosmic polarization or meteoritic delivery. A handedness that unifies biology across worlds, inviting reflection on how subtle asymmetries shape the grand symmetry of existence. Silicon-based life, speculative in carbon shadow, might arise in high-temperature environments like Titan's dunes, where alternative chemistries explore the boundaries of molecular possibility, a quiet diversification that enriches the tapestry of potential. Ammonia-based biochemistries, thriving in cold solvents on icy moons, could form slow metabolic cycles, a languid life form that parallels the unhurried pace of deep thought in repose. Boron-based alternatives in hypothetical high pH environments might catalyze reactions differently, expanding the chemical palette to include elements less common in our biology, a reminder that life's ingenuity knows few bounds in the universe's vast laboratory. Shadow biospheres on Earth, undiscovered microbial domains using different genetics, suggest even our home harbors hidden life, a microcosm of the solar system's concealed wonders waiting to be unveiled. The RNA world hypothesis, positing self-replicating molecules as life's dawn, finds echoes in meteoritic nucleobases, a primordial script that might script emergence on distant shores, where simple chains fold into complexity under cosmic conditions. As our journey softens to a close, dear listener, let these secrets of the solar system linger in your thoughts, a lullaby of stars and silence. You've traveled far tonight, through breaths of gas and waves of time, into the heart of infinity. May you now drift into peaceful slumber, carried on dreams among the stars. Good night, and sweet dreams in the gentle gravity of the cosmos.